Okay, sir. So I hope most of the participants and our guests are joined. So all of you are welcome to UL Space Club webinar session 57. So today we have an interesting topic which is very relevant in the modern era of technology development and research development. So we are very happy to welcome all of you to this exciting session on plasma related research and technologies. We have an expert from Institute for Plasma Research, Dr. 𝗬𝗨𝗪𝗏 sir, and we are very happy to have him here. Once again, all of you are welcome to this webinar session. We started a webinar session during the COVID pandemic situation when we were unable to conduct our offline activities, and we were thinking to conduct 5 to 6 webinar sessions, and we were getting huge response from all over India, especially from students of classes 8 to 12. So we were supposed to conduct more sessions, and we are on the 57th session of our webinar series. We are very happy to welcome all of you. I have few instructions for all of you before we go into the session or introduction of our session. First of all of you have to switch off your mic and camera unless you are asked to switch on it. When you are asking your question during the question answer session time, you can switch on your mic and camera. At that time, you are permitted to switch on your mic and camera. Otherwise, please try to switch off it throughout the session, because otherwise it will be an interruption to others when they are listening to our speaker, and it may be interrupt our YouTube stream, our video. Our meet is online streamed in our YouTube channel by one of our coordinator Adil, and so please don't try to make an interrupt. So please don't try to switch on your camera and mic. And please don't try to share your screen. Our speaker may sharing his screen, his slides with the content of our today's webinar. So please don't try to share your screen. It may be an interruption to other participants when they are listening to his screen. So please don't try to share your screen. And another thing which most of you may have already known, we have chat window in Google Meet. You can use the chat window for the questions. If you have any doubts or queries which you want to ask with our speaker, our guest, you can ask it in the chat window, and you will select that question for the question answer session. After the presentation and comments of our experts, we will have a question answer session which will be dealt by one of our student coordinators. So you can ask your questions at the question answer session time. For that, you have to type your questions in the chat window. That questions will be selected for the question answer session. So that's it. These are the instructions, and we will have a quiz based on this webinar topic, the link for this quiz, the link to access this quiz competition will be shared in the chat window after the vote of thanks of this session. So all of you are requested to attend the quiz competition, where the first prize winner will getting some rewards from UL Space Club. So that's it. Once again, all of you are welcome to this exciting session, and we are very happy to welcome all of you to this 57th session of our webinar series. Plasma is mankind's amazing tool. It's a very relevant topic which has to be discussed among the students who are the future of tomorrow, who are our future. So we have to discuss the relevant topic, and today we have an expert on that topic. I would like to welcome 𝗪𝗪𝗨𝗕 sir to welcome our speaker to give a detailed introduction about our today's session and our speaker. 𝗪𝗪𝗨𝗕 sir, over to you.
Okay, thank you, Varun. We are so happy to see you again in this month of April. And we have been sitting here for the past 3 years for our students, along with the prestigious and premier institute all over in Science Institute all over India and abroad. So today we are with a new topic, the plasma, an amazing tool for the mankind. The new thing, the plasma is a word, it's already known to us, but all of us know that it is in the sun and it is in lighting. We don't know what's its perspective, other areas there, but we get an opportunity to know it better. And fortunately, we got an opportunity to visit a plasma exhibition conducted by Institute of Plasma Research at Ernakulam last year. And then I wondered, that much of scope is there. Plasma is influencing all all the areas of human life and for using it in the field of energy, diagnosis, medicine, agriculture, everywhere. We could see the influence of plasma in the coming years. So the public, the academia, and all these areas has to get familiarized with the new technology, and students have greater scope for the future studies and research in this. In India, we have a research institute, Plasma Research Institute in Gujarat, in the banks of Sabarmati, and that institute accepted our invitation to speak about it. And today we are blessed to have Dr. Ravi Kumar for presenting for our students about this wonderful world of plasma. And from the previous webinar session, 56th session, we started a new system in our program, that is the co-host. The co-host is done by a premier or prestigious school nearby Calicut or any other part of the Kerala. In this 57th webinar session, the co-host is Calicut Girls Higher Secondary and Vocational Higher Secondary School, the prestigious school that was established in 1958. The next year of the formation of our state, Kerala, and that school situates in the heart of the city, and that is involved with a lot of science programs for our students, and ATL lab is there, lot of other student projects are there, everything is going on. So we are pleased to have the co-hosting of Calicut Vocational and Higher Secondary School for girls in this 57th webinar. And first of all, I welcome all of you to this forum. And our founder and mentor, 𝗚𝗍𝗫𝗏 is there. He started this UL Space Club in 2016 with the aegis of USCCS, Uganda Labor Contract Society. It's for the students, and we have been conducting several space camps and student projects and some other programs. But the COVID made us to engage with this webinar in the year of 2020, April, and we are continuously doing with the support of the scientists from different science institutes and education institutes all over India. And today, we are proudly introducing our guest here. This Dr. 𝗦𝗪𝗪𝗪𝗪𝗪 Ravi Kumar we are proud to say that he's born from Calicut, and he did his school at Cochin and graduated from Bharat Mata College, Cochin, and he has completed his post-graduation from Maharaja's College and PhD from CUSAT. And he joined the Institute of Plasma Research, Gandhinagar, Gujarat in 1993 as a scientist and worked on microwave free electron lasers, FEL. Experimental work led by him, IPR led to a generation of microwave FEL radiation from the magnetic nuclear device for very first time in India. He was awarded by the Japanese Society of Promotion of Science postdoctoral fellowship by Japanese government from 1999 to 2001. During his fellowship tenure, he worked on the experimental LINAC-based far infrared free electron laser at the Institute of Scientific and Industrial Research, Osaka University, Osaka, Japan. He was part of the outreach team at ISIR that was recorded higher harmonic emission from FEL for the first time using 10 megawatt RF electron LINAC. During 2007-2017, he was working on plasma work field acceleration project that was initiated at IPR as part of the basic plasma science program. He has also headed the computer division IPR during 2013-2017. During 2007-18, he played a lead role in establishing and running of the Board of Research Fusion Science and Technology, BRFST, which funded R&D project related to fusion science technology, which was later recast as Plasma Fusion Research Committee under the Board of Research in Nuclear Science of Department of Atomic Energy. Over 200 R&D collaborative and R&D projects were successfully undertaken during the period. Since 2018, he has been fully involved in IPR scientific outreach activities and over the last 2 years, he and his team has built up resources for various scientific outreach activities and also organized and participated in numerous national exhibitions and other science and technology events showcasing IPR research activities and achievements. He's also an active member of the Plasma Science Society of India since 2007. He currently holds the position of Scientific Officer H and heads the outreach division of Institute of Plasma Research, and his other interests are in photography, science communication, and music. So today we are proud to have a person who has connection with Calicut and who is engaged with science activities to educate all the public and scholars all over India about the plasma and its scope. Today also, the students will get a glimpse of these areas from his own words. And I invite Dr. 𝗬𝗓𝗪𝗓 to this forum of UL Space Club to render his speech. And before we are starting our session, it's the co-host is our Calicut Girls Higher Secondary School, and the principal of the school, Honorable 𝗦𝗣𝗓𝗪 Manipuram, is presiding these sessions, and I invite 𝗦𝗣𝗓𝗪 to. Okay, Sabir sir, anything?
Okay, Abdul sir and Abdul sir.
Sorry, Abdul sir, to this forum. Sorry for the name change, and I welcome Abdul sir. And I have gone there as a school earlier, and there was wonderful things are happening for the students there. And in addition to that, I happily announced that Institute of Plasma Research is agreed to conduct a plasma exhibition at Calicut, our hometown, with the direction of Ravi Kumar sir, and we'll get information regarding that during his talk. And I invite all the dignitaries who gathered here, including 𝗚𝗍𝗪𝗏 sir, 𝗪𝗏𝗪𝗏 sir, our 𝗚𝗍𝗪𝗏𝗏 sir. And with all your permission, I invite Abdul sir to make his presidential address. Welcome, sir.
Respected dignitaries on the floor and dear students. First of all, let me express my gratitude to the organizing committee, to the organizers, UL Space Club, for selecting our school, the first and only NABET accredited school in general education in Kerala, to co-host this program. Really, Kuti sir had come to our school, and Sajil sir had also come to our school as part of different programs. So really, I think this platform will give and is giving a golden opportunities to develop a scientific temper and scientific activities that is happening around the world through this club. So I'm very, very happy that our students also got a chance to participate in this program and to co-host this program. So this is a technical session. So I don't like to prolong my speech because all of us are waiting for the listening the words of the chief guest. So once again, thank you very much for giving our school a chance to co-host this program. So that's all for now. Thank you very much.
Thank you, Abdul sir, for your kind words. And it's without taking much more time, I invite our honorable guest, Dr. 𝗬𝗓𝗪𝗏, to present his talk on plasma, the amazing tool for mankind. Welcome, sir.
It's been quite a while since I've given a talk online, because after December 2021, I don't think we have ever had an online session. So, but that's okay. So, today's talk I will try to keep, because I didn't know what is the cross section of the viewers. So I tried to keep it as simple as possible. I'll talk about some problem with my tube light, so my video might flash like this. But don't worry about that. So this talk is going to be an introduction to plasma, and then I will switch over to some of the applications that some of the many. There are hundreds of applications, but which obviously I cannot deal with within an hour. So this talk will have a few of the interesting applications that plasma can do with. So without much ado, I'll just share my screen. Are you able to see it?
Yes, sir. It's visible.
Okay.
It's visible.
Okay, so it's visible now. So what you see here is our campus, Institute for Plasma Research. It is in Gandhinagar, as Shajin said. It's a very green campus, and if any one of you get an opportunity to visit Ahmedabad, please come to our institute. So the question now begs as to what is the importance of plasma? Why should you study plasma? And if at all you have to study plasma, how do we study plasma? So let us look at this. Plasma is almost 99.999% of the whole universe. That is, with no exceptions there. Everything, our Earth, solar system, the rest of the known universe, owe existence to plasma because everything started off from a Big Bang, which is an exotic plasma by itself. And plasma can be applied to solve many problems in our walk of different walks of life. As I said, plasma is all around us. Plasma is there everywhere. And the main point is number 3 here, number 4 here. Plasma might someday provide the ideal solution to Earth's energy and pollution problems. And also, it's a very relatively new topic in Indian curriculum. It's not generally taught unless you reach your master's level. All they teach in school is plasma is a first state of matter. That's all. Nothing more than that. So by the end of today's talk, my aim would be to at least educate you and introduce you to this wonderful world of plasma. So when mankind first learned to use fire, he was actually using plasma. So I would say that plasma is one of the oldest science in this earth. So if you study plasma physics, that means you are you can say that mankind's oldest science is what you're learning. And because fire, as I say, is the simplest form of plasma that we have. So before I get into my talk, I just want you to understand some concepts that our ancestors used to use, like the concept of Panchamahabhutas. That is, our ancestors had an idea of what our surroundings were. So they called it Prithvi, Jal, Vayu, Agni, and Akash. So you can easily identify Prithvi with solid, Jal with liquid, air with gas. But the fourth and fifth ones, Agni, that is fire, and Akash, that is space. These two combined, or these two today, we term it as plasma. So our ancestors did have a very good idea as to what are the different states of matter for that matter. Now let us see what exactly is plasma. So it was first demonstrated by Sir William Crookes, and what he did was he took a vacuum chamber. Everybody must have seen this. It's called a Crookes tube. It's a vacuum tube with 2 electrodes and gas at low pressure. And when high voltage is applied to it, he found that it used to form some kind of radiant matter. So that is what first he just termed it as radiant matter. Not until 1928 when Irving Langmuir, who is one of the supposed to be the father of plasma physics, he renamed it as plasma. And for him, it means moldable substance. But in his students had written that he named it plasma simply because this plasma reminded him of the blood plasma, because the blood plasma carries all the components of the plasma. The same way, this radiant matter carried all the components of the plasma. But what are the components of plasma? Let us look at that. So again, how do you get to the state of plasma? This is something that is taught in schools, that you have solid, liquid, gas, and you take it one step further, you have the plasma state. So how do you convert from one state to another? It's very common that ice, you take example as ice, you give it some heat, you get water. You give it some more heat, you get steam. You give some more heat, but how much heat has to be given? If you expose steam to about 12,000 degrees centigrade of heat, you can convert it into plasma, but you don't get water plasma. By that temperature, your water is already broken down into oxygen and hydrogen. So you have a combination of oxygen and hydrogen plasma. So essentially, you have to give it energy, and as you increase the energy that you give to it, you can change it from one state of the matter to other. Uh, but then I always ask the question: but why do they call plasma the first state? It should have been first state, right? Because everything that we know of today has come from the state of plasma. You can just think about it. So now what does plasma actually contain? Let us take a simple hydrogen atom. It just has one electron. But if you give it sufficient amount of energy to knock out that electron, what do you have? This is the hydrogen atom. And this, what you see here is H plus. Why do you get H plus? Because you remove an electron from the atom, it is no longer neutral. So you have an electron here and an ion. And this whole combination of electrons, ions, and unionized atom is called the plasma. You also find photons in the plasma. Plasma has a color. Why does plasma have a color? Because inside the plasma, at some point of time, this hydrogen ion will meet an electron. When they meet, they recombine, and whatever energy was used up to make the plasma is released as a photon. And that photon will depend, the color of the photon, the wavelength of the photon will depend upon how much energy is required to ionize the gas. Hydrogen plasma is usually between pink and magenta in color. And plasma has a very unique feature. If you look at this whole ensemble from outside, it will look neutral. But if you go inside the plasma, depending on where you're probing, the charge will be different. If I'm probing here, it will be negative. If I probe here, it will be positive. So it is like, the old, joint families. From outside, we look at it, everything is hunky-dory. But if you go inside the family, you will find the sister-in-law is not in good terms with the other sister-in-law. The mother-in-law is having problems. So all these things happen. So this is called pseudo-neutrality. Plasma is pseudo-neutral. It is neutral only from outside. If you go inside the plasma, it is non-neutral, and that has its plus and minus points. The key thing in plasma is that this will remain in state of plasma only as long as you continue providing the energy. If you remove the energy, everything will become the gas from which it became a plasma. So let us look at some natural plasmas first, and then we'll go ahead. So as I said, fire is one of the most fundamental and simple plasma that you can create. Solar flares. We all have heard of it, probably seen it through images like this. Some of you would have also observed it through a telescope. So this sun is nothing but a huge ball of plasma, massive ball of plasma. And then you have what is called as corona discharge, where if you have very pointed electrodes which are connected to high voltage, the charge density at those points will increase so much that it can ionize the air around it. So you'll find it in high voltage lines, etc. And in this case, if you look at this, small sparks flying across the aircraft windscreen as a plane flies through a storm. This is another example of corona discharge. These are called St. Elmo's fire. And of course, you have comet. A comet has a dust tail and a non-dusty tail. So the ionic tail of the comet is a plasma. And as I said, stars and interstellar space. The entire universe is in a state of plasma. So depending on where you are, only the density varies, nothing else. And of course, the lightning is the free nature show of plasma. And I don't know how many of you have seen the Aurora Borealis or Aurora Australis, depending on the hemisphere you're in. These are also very, very classic examples of plasma in nature. So another important thing about plasma is that it has no other system in this universe has such a large dynamic range. By dynamic range, I mean that plasma is able to exist in an extreme range of temperature as well as densities. You look at this y-axis here, it is from room temperature to almost 10 to the power of 10 degrees centigrade. And in terms of density, it's almost 10 to the power of 3 to 10 to the power of 33. So you can imagine that the same plasma can exist in this entire range of densities and temperatures. And depending on what is the application that we want to use, we have to choose the plasma at the right density and at the right temperature. Now, before I get into anything, I just want to clear two simple concepts. That is, if you expose a charged particle, whether electron or an ion, to a magnetic field, or for that matter to an electric field, they will start gyrating. And ions being more heavy, they move much slower. Electrons are being smaller, they move faster. Now, for example, now what happens? See this: the electrons and ions move in random motion. But the moment you apply a magnetic field, watch here. Once a magnetic field is applied, you will see that all the charged particles are trapped along the magnetic field lines. I would compare this to a classroom without teacher. When the teacher is not there in the class, the entire students are in random motion, doing whatever they want. But the moment the teacher arrives in the class, everybody is in order. They sit in their seats and they behave. In the same way, the electrons and ions can be controlled using a magnetic field and electric field for that matter, but they're deflected. Now, this is very important because in any way, if you want to control a plasma, you will require a magnetic field. Now, once again, I told the sun is a big ball of plasma, right? So you can see, and sun has something called a solar flare. You can see the solar flare. Look at the size of Earth. It's extremely tiny as compared to the solar flare. And this keeps coming all the time from the sun. But Earth is still here, right? Why is that? Simply because there is something called the Earth's magnetic field. Now, Earth's magnetic field, what it does is, it deflects the charged particles away from Earth. But even so, watch this video. You can see the charged particles from the sun coming towards Earth, and Earth's magnetic field is being pushed backwards. But there will be a point when these magnetic field lines reconnect. And through these reconnected lines, you have charged particles coming into the polar regions of the Earth. That is where you get the aurora. Now, for a comparison, you can see the fridge magnet in your house fridge is about 10 Gauss. Earth's magnetic field is just 0.5 Gauss. And if you take an MRI machine that you have in hospitals, that's about 15,000 Gauss. You can see how such a small magnetic field of Earth has been protecting us for millions of years. So if the Earth's magnetic field can control charged particles, why not we use magnetic field itself to control very hot plasma that we have to use at some point? Now, I told you that the flame is the simplest form of plasma that we can find. You don't have to believe me just because I told. Let us scientifically establish that a flame has charged particles. But how does a flame make plasma? Because flame has a fire, obviously, and the fire is at a temperature of 1500 degrees temperature. Because of the high temperature, the air around the flame, basically nitrogen and oxygen, they tend to get ionized a little bit. So that is how the flame has some kind of charged particles in it. So we will see how. So as I said, you can control an electric and magnetic field through. You can control a plasma, electric and magnetic field. Let us prove that. Now let us take this candle here. There are high voltage points. You can see that when I apply voltage at these two electrodes, the flame gets bent towards one side. See that? So that is now showing that this plasma this flame does have some kind of charged particles. Now let us look at magnetic field. There are two massive coils here producing high magnetic field. You have a candle in the middle. Watch this bulb. When this bulb lights up, that means the magnet is on. See that? When the magnet is on, the flame gets compressed. The plasma is confined. This word is important. Remember this word. So plasma can be confined using magnetic field. You can see if you keep increasing the magnetic field, you can see that the flame becomes smaller and smaller and smaller. It's called quenching of the flame. Lightning is another classic example of plasma that nature has. And one small lightning discharge can discharge about 30 lakh volts and about 30,000 amperes in 1 microsecond. And this is equivalent to power that can keep a 60-watt bulb on for 6 months. So there's tremendous amount of energy in every lightning. Unfortunately, technology is not yet evolved, which you can tap electricity from the lightning. But eventually, mankind will find out methods to extract energy from lightning. And as you know, lightning has two parts. One is which goes from the ground to the sky, and one part which comes from the sky to the ground. Normally, we don't see the positive leader. It's only the step leader that we normally get to see. But lightning is consisting of two parts. Now let us see, how do you make plasma? I've talked about what is plasma and what does plasma contain. So this first line that I said, as long as energy provided is greater than the ionization energy, plasma can be produced. Ionization energy is nothing but the minimum energy required to knock out one electron from that. So you have flame, as I said, flame gives because of temperature. So it is thermal energy. Okay? This is spark because it's due to electrical energy. Now this one, you can see there's a green light coming. There's infrared laser coming from the top. You cannot see it because it's infrared. But when it strikes a copper target, you can see green color. So that is copper plasma. And that is optical energy. And finally, through radio frequency. If you put an old dead tube light inside a microwave oven and switch on the microwave, you will see that light glows. That is because the microwave radiation is sufficient enough to ionize the mercury inside the tube light. So it is energy that is most important, not how you give it. And again, depending on the application that you want to use, you have to choose the right kind of energy to create your plasma. When you start at home, you are using plasma every day. When you switch on your tube light, the old tube, not the LED ones, the old tube lights, when you switch on a tube light, you're creating a plasma. When you use the gas lighter, there's a small spark inside this. All of you must have seen that. When you use that, then you're creating plasma. When you light the gas light, you're creating plasma. You create any spark, you're actually creating plasma. So you have no escape from plasma. From the time you wake up in the morning, you are using plasma. Now let us look at some man-made plasmas. So you can see cutting welding is the most popular kind of application here. And you have this neon lamp. These days nobody uses neon lamps because LEDs have completely taken over the market. But these are nothing but different gases filled inside evacuated tubes, and you make a electrical discharge. And then you have normal glow discharges. You have these two are hot plasmas that you see inside a fusion device called a tokamak. And on the top, you can see what is called as spacecraft propulsion systems or ion thrusters or hall thrusters, whatever you want to call it. And these are plasma torches, which is extremely high temperatures. The temperature here is anything between 5,000 to 10,000 degrees centigrade. And this is again for an industrial application. But these are some of the man-made plasmas. And here, dusty plasma, as you see here, is one again very important because that is the main plasma that is the reason for formation of stars or formation of planets or formation of rings. There's Saturn's rings. They're nothing but the dusty plasma, having particles from millimeters to few tens of centimeters in size. So dusty plasma is again an important aspect of plasma. Now let us see why do different plasma have different colors. I told you that the ionization energy is what is required to create the plasma. But when the ions and electrons recombine, that energy which is required, which is taken up by the atom to ionize itself, is returned back as a photon. You can see right from helium to mercury, you can see they offer different colors. And this is again an important aspect because by looking at the color, I can by studying the color actually, I can get a lot of information about the plasma that I am studying. Now let us look at something the concept of hot and cold plasma. Now I don't know how many of you are familiar with how a tube light works because nobody uses them these days. But in our era, tube lights were the main lighting that we had. So tube light is nothing but an evacuated tube. It has a very small quantity of mercury and two filaments on both sides producing electrons. When these electrons are rejected by the electrodes or the filament, they form mercury plasma. Mercury plasma is actually violet in color, not white. It is white. The tubelite gives white light because of the phosphorescent coating that is inside the tube, which converts this UV light into white light. Now, why am I talking about tube light? Now, if you look at a tube light very carefully, you will find there's a term called 6500 Kelvin here, which is again Kelvin is a unit of temperature. How come a tube light can have such a high temperature? So this is nothing but it's a wavelength of light that an ideal black body will emit at that temperature. So the white light that it gives you is what a black body will emit at 6500 Kelvin. Having said that, every electron inside this tube light has a temperature of 11,000 degrees centigrade. Every electron, but the tube light you can still touch. Why is that? It's simply because the number of ionized atoms is very, very less than 1%. So that is what differentiates a hot plasma from a cold plasma. A hot plasma, the ionization is nearly 100%, and in a cold plasma, the ionization is maybe a few percentage. That is all. You can see surface of the sun, lightning, plasma welding, everything uses very hot plasma. Cold plasma is like tube light, neon lamps, atmospheric plasmas, like the aurora. It's all cold plasma. Now, I just want to take this concept one more step. Imagine you have a room and you have one candle sitting in the center of the room. And each candle, the flame temperature is about 1500 degrees centigrade. If you put your hand in near the door, you probably won't feel the heat. But if you put about tens of thousands of candles in that same room, and now if you keep your hand, you will start feeling the heat. Why is that? Because the collective temperature is now high. In the same way, it's the same concept for hot and cold plasma. The only difference being that in a cold plasma, the number of ionization is very low, and in a hot plasma, the ionization is almost 100%. Now let us look at a classic example of it's the same plasma in two modes, hot and cold. Now let us see. In this case, it's a hot plasma. I can even light a matchstick. Then obviously I cannot put my finger on that. It can burn a paper. Now the same plasma I just converted into a cold plasma. Now see, I can touch it. It doesn't burn anything. So the funny thing is that the most interesting thing is that the same plasma, just by changing how you produce it, can be a hot plasma and a cold plasma. This is extremely crucial because this will determine what kind of applications the plasma can be used for. Now we have produced plasma. So now you have to study it. As I said, plasma can be extremely cold at room temperature, and it can be extremely hot. If you ask me how hot, I will say hundreds of millions of degrees centigrade. So you have to study it, right? So you have to study it remotely without touching the plasma. So that is what is called a non-contact method. There are about 30 or 40 such methods, but I will confine myself to just two methods which you can easily identify with. One is spectroscopy, and other is microwave, reflectometry, or interferometry. This name sounds very complex, but it is not. Let us get into one of this. So basically, what any plasma scientist requires is the plasma temperature and the plasma density. These are the two major components that any plasma scientist wants to understand and know. So let us look at the first thing, that is studying plasma through light. So as I said, plasma produces light. Now I can capture that light and study that light. But why is that relevant? Why am I showing planets and all that? It is the same technique by which astronomers understand what materials are there in a planet, or whether this planet has an atmosphere or not. How is that done? Because of something called as emission and absorption spectrum. Any hot body will give a continuous spectrum. Like if you take a sunlight, you look at it, you get a continuous spectrum with Vibgyor. But if you pass that Vibgyor light through some cold gas, that cold gas will absorb some particular lines. For example, if you pass white light through sodium will absorb its two yellow lines, and you will have black lines instead. So by studying the signatures of each of the materials, you can actually find out what is the content in the plasma, and also you can understand what are the components of the plasma. The short video will tell you how exactly to understand what gases are there, what is atmosphere in the plasma. So when the planet passes through the front of the sun, part of the light of the sun will pass through the atmosphere and create an absorption spectrum. So you can see these are dark lines superimposed on the sun, on the light from that sun. If you combine these two, or if you subtract these two, you will get basically the spectrum of the elements that are present in that planet. And this can be easily identified because every gas, every element has what is called as a signature spectrum. And from the signature spectrum, you can exactly identify what is the gases. And actually, you can when look at the temperature of the gases there by using spectroscopy. So the second example is radio waves. Now, all of you must have noticed that you can hear BBC London or All India Radio Delhi or Radio America, whatever, sitting at your home, but you cannot hear FM radio from the next town. Why is that? Simply because the frequency of radiation. Our Earth has something called as an ionosphere, and the name ionosphere, it is obvious that it has ions and it is charged particles in it. So if you take the amplitude model, AM radiation, radio waves, which is from 535 to 1705 kilohertz, they get reflected by this ionosphere, whereas FM radiation, which is in the megahertz, is transparent. The ionosphere is transparent. It transmits away. That is why you cannot get your FM radio or TV from your neighboring town where you can hear radio stations far away. And the same thing is for plasma. If you take plasma inside and put microwave inside, depending on the density and temperature of the plasma, only part of it is reflected, part is absorbed. By knowing how much is reflected and how much is absorbed, I can exactly tell what is the density of the plasma, what is the temperature of the plasma. These are the two techniques that I wanted to talk to you about. So there are various other techniques, and plasma scientists use them depending on what kind of plasma they want to study. Now, let us come to, I'm slowly getting into plasma applications. Why is plasma important? It is simply important because there's tremendous wide range applications. You can see right from aerospace, defense, automobiles, biomedicine, computers, waste management, paper, textiles, telecommunications, solar energy, optics. Everywhere, it plays an important role. And of course, there are extremely high advanced applications, which I will not be talking about now. I will confine myself to plasma applications which affect our day-to-day life. Now, as I said, remember we talked about the dynamic range in about hot and cold plasma in a few slides before. Now that is important because plasma has to be tailor-made to suit the application that you want to use. So let's take, for example, hot plasma and cold plasma. They're also called hot plasma called thermal plasma because hot is thermal and cold is non-thermal plasma. You can see nuclear waste management, ceramic spray coatings, cutting, welding, material processing, hot plasmas, sterilization material, wound healing, reducing seed germination time, treatment of textiles and plastics, and also dental medicine. We will now briefly look at some of the applications, not all, but I will try to cover most of these areas. So let us simply start with medical application. Why is the plasma good for medical application? Simply because when you create a plasma in air, these are the components that are produced. There are free radicals, there is ozone, there is negative ions, there is UV radiation, positive ions, and electrons. And these things are the most important. For example, when you create a plasma in air, you have what is called as reactive oxygen and reactive nitrogen. Why only reactive oxygen and nitrogen? Because our atmosphere is predominantly nitrogen and oxygen. So you have reactive oxygen and reactive nitrogen. And these have very, very reactive properties. We'll get to that. Now take a look at this plasma torch. This is my finger here. I'm touching the plasma. This is what I said. The same plasma can exist as extremely hot and also at room temperature. So this is a plasma torch that is basically used for medical applications. Now we can see sterilization, skin infections, reduction of blood clotting time, dentistry, cancer, faster healing of wounds. There are a plethora of applications. Now I can show you how in one of our projects we've seen. See this doctor is applying the plasma onto the fungal infection of a farmer. Now, fungal infections are very difficult to cure because when you apply the medicine, it will go away. But once the medicine is gone, it will come back again. But by applying, you can see that within 3 weeks of application, the entire fungal infection was dead. So this is the potential tool for medicine, but it has to first qualify the what should I say, the protocols for qualifying this as a medical equipment. That is being done now. And you can see that another important thing is blood clotting. Natural blood will clot in about 200 seconds unless you are a hemophilic patient. If you're not a hemophilic patient, normal, if you have a cut in your arm or wherever, it takes about 200 seconds for the blood to clot. But if you apply plasma, same kind of plasma to the wound, the blood will clot in 20 seconds. That is 10 times faster. Just imagine this, what implications this will have in emergency situations. An accident has happened and our 108 ambulance comes here, and usually patients die because of blood loss. It's called trauma induced by blood loss. But so if you stop the blood loss, the chances that the patient will survive increases so much. So those are the two ones. Of course, there is general sterilization, cancer treatment, and dental medicine also are parts of are applications of medical applications. For example, now dental. Now you can see if you have done a root canal treatment, anyone, you will see that the doctor takes at least 3 sittings. One sitting to make the hole, and then second sitting to ensure that all the infection is gone. The third sitting probably you will fill it up and put the cap. Why does it have to take so long? Because the doctor has to first ensure that there is no infection inside the cavity, and that can be done in just one sitting if you use a cold plasma jet. Like the cold plasma can go into the teeth cavity and then kill all the pathogens there, so the teeth is ready for taking the filling and the cap just in one sitting. It also used for cleaning of teeth and the removing of cavities again. Now, there are a lot of plasma applications for self-grooming, although these are not recommended by doctors for some reason, but people still use. You have, a plasma comb, which is good for dandruff and lice, and there are also various plasma treatment for nail fungus, for plasma sterilizing, and also treatment of wound. And you can see how this lady is using this plasma stick. It's a radio frequency plasma. So when inside this blob, there is a plasma, and since it is an RF plasma, it can interact with outside materials through capacitance effect. So what happens is when you put it on your skin, you feel a very tingling effect. That tingling effect is supposed to stimulate the blood vessels, bring more blood to the face, so your face glows. So there are various techniques like this which people use. This is for sterilization. If you go to hospitals, you will see what is called as an autoclave. An autoclave is a device that basically sterilizes medical equipment. But the problem with an autoclave is it uses hot steam at high pressure. You cannot sterilize plastics or things that are having low melting point. But by using plasma sterilizers, I can sterilize any material irrespective of what material it is made of. And this is what a sterilizer looks like. And you can see that the pink glow of nitrogen gas is there inside. So you keep your materials like this, close it, and activate the plasma. This is one of the plasma surface sterilizer that IPR had developed during COVID. So this is to sterilize surfaces like on a bed or a seat or a table. You can use the very compact thing. You can hold it in your hand and you can wave it over the surface and the plasma here. You can see the pink color in the plasma here. That will produce the reactive oxygen and reactive nitrogen, which will sterilize the surface. This again are large plasma sterilizers used for AC system. For example, if you want to have a sterilized room, like for example ICU, intensive care unit need to be extremely sterile atmosphere that infections don't get in and affect the patients. So if you attach this to the AC unit, as the air passes through this, with each pass, all the bacteria or all the pathogens that are in the air are trapped here and killed. So eventually your room will be extremely sterile. So these are concepts for hand sanitizers, where instead of using the sanitizing gel, you just put your hand into the plasma chamber, and since plasma behaves like a liquid, it will cover all the parts of your hand, effectively sterilizing them in just a couple of seconds. So these are some concepts of sterilizing using plasma. And that is, why does the plasma sterilize? As I told you, reactive oxygen and reactive nitrogen species, when they encounter a pathogen, a cell, they can actually break the cell wall. Once you break the cell wall, pores on the surface. What does micropores do? They help in absorption of water. And a seed germinates only when the water percolates from outside to the center of the seed. And if you increase that speed, you can increase the germination. Now you can ask me why do I want to decrease germination time? Just imagine if a rice farmer has to plant rice, he has to do it 14 days in advance, because it takes 14 days from the seed to become the sapling. It can be transplanted, and the day he has to transplant, there has to be rain. So if it does not rain, all the saplings are gone. So I can reduce that time so that the farmer does not have to lose his precious seeds. Now you can see this is a study which we did on wheat. So this is plasma treated wheat, and this is non-plasma treated. They could find a 14% increase in yield, and the general health of the plants also was much better in the plasma activated seeds. So this is a very important application of plasma in terms of agriculture. Now let us go to industrial applications. This is what is called as plasma nitrating. Any tools that undergo wear and tear, like gears, piston, cutting tools, have a lifetime because it will wear. But if we treat with a combination of hydrogen and nitrogen plasma, what happens is it creates a thin layer of nitrides, metal nitrides on the surface, and this is very small, about few hundred microns. You can see here the hardness of the surface is hydrophobia. That means it doesn't like water. And for many applications, let us take a look at this. Now this is the material does not stick to the surface at all. There's no corrosion. You can make waterproof dresses by treating your textile with special kinds of plasma. This is another thing about textiles again. This is what is called as Angora Rabbit. Suppose it has one of the softest wools, but the problem with the softest is that you cannot weave it into a thread. So you can see these two pictures. This is the electron microscope image of a single thread, not thread actually, fiber, and this is after plasma treatment. Cotton comes out of the mill. It is passing through various plasma inside this, and finally this cloth now is ready for dyeing without washing. It uses no water at all, and for dyeing, every ream of cotton requires 90,000 liters of water. So you can imagine how much of environment impact this machine will have. Now, another thing that is commonly used is for etching materials on cloth. For example, this denim, we have this stone wash. This is usually done by chemicals or by lasers. But with plasma also, you can do that by using different small kinds of plasma etching like this. So this, now if you watch this image. This is the plasma coming out of this machine, and this is the denim material. Again, this is cold plasma. So this denim material can actually etch out the dye in the cloth without damaging the cloth. So as the cloth is coming out of the mill, the plasma can print out whatever design the customer wants. Again, this is no water is used. This can also be used for plastic material where plastic and ink doesn't adhere well. So if you treat the plastic with plasma, the ink gets stuck to it much better. There is less wastage. I don't recommend using plastic, but we're not there yet. Now let us come to space, which is important to this group. Rocket propulsion is one of the most important applications of plasma in space, and all of you know that for taking the spacecraft from ground to space, you need high impulse rockets. That's why you have massive rockets that burn for a few minutes and everything is gone, and the rocket has reached the space. But once the rocket has reached the space, there is microgravity, or gravity is nearly zero, and there is no atmosphere. There is no drag. So even a small force will take the rocket over a long distance. That is why you can see the Apollo rockets is such a huge rocket, whereas the ion thrusters are extremely small. Now, a classic example is the 𝗖𝗍𝗨𝗕 spacecraft, which will be launched in October this year. And this is the spacecraft that will fly to a fully metal asteroid, and that uses just 4 ion engines. And these ion engines produce such a small force. That force is not more than as keeping 5 coins in your hand. That's the force it generates. But over a long period, it can generate a velocity of 320,000 kilometers per hour for that spacecraft. You can imagine how powerful such small engines are. That is why now all agencies are investing heavily on ion thrusters and trying to see how they can be used. So these are the engines. This is one developed by ISRO, which is being tested inside the vacuum chamber. And this again is another engine which is being developed by a company called 𝗬𝗕𝗓𝗕 Aerospace in Bangalore. So just to sorry. I'll come back and show. Sorry. Just give me a second. I think
It's okay, sir. It's okay.
No, I'm just, by mistake, I did hit escape. Yeah, got it. Okay, am I back?
Yes, sir. Yes, sir. It's visible.
Okay. Oh, it's still not working. Anyway, fine. Let me come back to that. Don't worry. So this is how the ion thruster works. You create a plasma inside. You strip away the electrons, and then this ions are accelerated outside. And when the ions are accelerated in this direction, due to Newton's third law, the spacecraft is propelled in the opposite direction. That is how the space, the rocket engine, the ion rocket engines they work. And NASA is also developing very high power plasma engines, which would take a spacecraft. Normally, it could take anywhere between 6 to 9 months. So these are basically going to be the main engines travel, because they don't require high impulse engines. So that is the difference. So another thing is again active flow control. Plasma can actually control active flow. Let's just watch this video. This is an aircraft wing, and this when there is no plasma, turbulence is produced. But the moment plasma is on, plasma is surface. You can see are perfectly non-turbulent. All this plasma, you can pushing a 10-kilo ball on top. So that is kind of thrust. The clock and currents by electromagnetic waves. But if you carry a metallic antenna, that becomes very heavy. So you can actually use a plastic antenna, and then you coat it with metal using plasma. So this is an important application of plasma that was developed for ISRO a long time back, and it's the same can be used to keep your brassware constantly shining, and you can make reflectors of plastics. If you look at your car headlight reflector, it is not metallic; it is plastic, and this is can be done using plasma. It's much cheaper methods and more environment friendly. Also coated on solar cells with anti-reflection. Efficiency of the solar cells can be increased. Now, another fascinating application of plasma is lighting. Now, if you have a plasma discharge with the right kind of gas mixture, it can produce light that is very close to natural sunlight. So this company has produced this lamp. It has a small tube inside, an RF generator. So the plasma inside is almost like sunlight. You can see that the orange line here corresponds to sunlight. The green light is corresponding to the plasma lamp. Now you can just imagine if we can replicate solar sunlight. It is so good because currently no light, no artificial light directly duplicate the sunlight. So you can do farming during the night, and also it can be used for countries which have very less sunlight. If you go to Arctic Circle, in winters you have extremely short days. So how do they do farming? So you need sunlight, and also certain animals have sunlight. So sunlight is extremely important for some sector culture and farming, and that is why this is very popular application of plasma light. And because of persistence of vision, our eye will think that the image is moving there. So this is how laser can be used to create images in space without a screen. So at a much smaller scale, watch this. See this? See that shape of love is in air without anything. The laser is producing those spots there, and those can be made in display. Okay, today this is only in the lab, but I don't know, maybe 20, 30 years from now, this is going to be a very standard practice for very large displays that can be done with lasers. If flash a laser very fast, our eye, because of persistence of vision, will see the image. Now, another very fascinating application which I saw was, dust cleaning. Now, you may imagine spacecraft is in, for example, Ingenuity in Mars. After many months, look at the image of the machine there. It is completely dust, and the first rover is already dead because the solar cell is completely covered with Martian dust. So this is a simple experiment that in university did. So these are solar cells. These are what they imitated Martian soil. So when you apply the plasma, watch this. This is the dust. When he applies the plasma on it, because the dust has completely vanished. In 3 shots, the dust has completely gone. So this is one technique that scientists plan to use in future Mars programs, so that they can keep their detectors and the surfaces optically clean using. And the main advantage is that it can be directly applied because the Martian atmospheric pressure is about 5 torr, so they don't need any vacuum or anything. Directly apply the voltage, create the plasma pulse that will clear the surface. So these are some of the fascinating applications of plasma. Futuristic, I would not have to say. Everybody uses it now, and the temperatures can be extremely high. So cutting can be much more efficient than conventional cutting and arc welding. Now, another application is surface cleaning. So how do you remove rust? You have to either use a grinding wheel, or now we have laser-based cleaning tools. So laser beam is coming from the top here. You can see the beam now. Just a minute. From the gun, see this gun? The laser beam comes out from that, spreads over this, and it actually creates the plasma, and that plasma can completely ablate the surface off. You can see all the rust is removed. So this is also a very popular industrial tool now, which is being used by industry. And this again, now I'll come to some more hot plasma applications. So these are what are called as plasma torches, extremely high temperature. These are gas torches. These are electrode torches. The temperatures here in this zone is anything between 5,000 to 10,000 degrees centigrade. These are purely industrial application materials. Now, one major application is the plasma pyrolysis. Pyrolysis is nothing but where you can break down material without oxygen. So by basically used for waste treatment. You can see conventional incineration and plasma pyrolysis on every carbon monoxide and oxides of nitrogen, particulate matter, and dioxins and fluoride. They are most important now. Recently, from this Brahmapuram thing, people are saying that lots of dioxins and fluorides are produced because of burning plasma. By using a plasma pyrolysis machine, the amount of fluorides is 1 order magnitude than permissible conventional techniques. So plasma pyrolysis is a very important technique which we are now propagating mostly for medical waste. Simply because medical waste is a very important thing, it has to be eliminated. So what normal hospitals do is burn it. But if you burn medical waste, it has its own problems. So plasma pyrolysis is one major thing. We've installed almost 20 hospitals across across the country. I think one in Tirunelveli also. So, and these things are good for medical waste, any kind of waste that does not contain too much of water. Can be solid, liquid, slurry, anything. So this is one of the important aspects of pyrolysis, and most important is residue is very less, only 0.5 kg for 100 kg of waste. Again, gasification. You can extract gases from using plasma. These gases can be used for many industrial purposes. Something called as synthetic gas. It's a mixture of carbon monoxide and hydrogen. This can be used to produce fuels, or it can be used as an additive to CNG and PNG and things like that. Single 120 megawatt plasma gasification consume up to 3,000 tons of garbage every day. That is enough to produce energy for 36,000 homes per day. And our governments are still not woken up to the great waste problem that we are going to face in the next 20-30 years. And if we don't do anything about it, our future generations will really have a tough time. This is again for nanoparticles. Nanoparticles have lots of applications. I'm not going into this. One application that we found was stain removal. So this is the plasma chamber that is produces the nanoparticles. You can see that if you stain a cotton cloth that has been treated with nanoparticles, tea, coffee, and turmeric, just stain, all you have to do is to keep it in the sunlight. The sunlight activates the nanoparticles, and within 2 hours, the turmeric stain is completely gone. See this? So this again has a lot of applications. Again, for plasma torch for automobile parts. In automobile parts, it gets very hot. You cannot put paint, because paint will just burn off. What's called as ceramic coatings. These are ceramic coated automobile parts, which you can see how the person is coating the surface using a plasma. This is a very major application for ceramic coatings. Now, another fascinating thing is lightning arresting using plasma. Normally, we use a lightning arrestor on top of the house, and that will, but for entirely in full lecture. So I'll just go through a simple what is fusion. As compared to fission and fusion, one you have to bake, other you have to join. And fusion is what happens sun. Our sun has about 600 million nitrogen every second is converted to helium, and that produces plenty of energy. And this is going to be our future energy source. Now, how does fusion work? We take deuterium and tritium, which are nothing but isotopes of hydrogen. We combine them. You're going to get one helium and a neutron. But you can see the AMU, the weight is different. See, here it is 5.03 AMU. Once the fusion happens, it's only 5.01. It is this 0.02 AMU that is converted to energy equation. So 14.5, 17.6 MeV of energy is produced using one fusion reaction. How much is this energy? We take out this neutron here, catch out the neutron and let it go. It will reach the moon in 3 seconds. That is the kind of kinetic energy that neutron has. So if I stop that neutron, I can extract the energy from it. That's how fusion works. Now, just a combination of various other applications which I am not able to tell you. One is exhaust. You can purify exhaust using plasma. Cancer treatment. With big LED, big plasma TVs. Nobody uses them now, but these were at one time very popular. They were very bright, and these are plasma spark gaps. Various sparks coming out of a spark gap, so it increases the fuel, the burning efficiency, and so the efficiency of the engine is increased. Also decreases the pollution rate. These are called plasma antennae. Humans can.
Rajesh, please be there. You will get your time. Okay, you will be called.
Okay.
Play the video for you.
Okay, sir.
No, it doesn't play. No. Anyway, that's okay. I don't think it will play. Okay, now you can ask your question. Please switch on your video. I want to see who's asking.
Okay, sir. Be there. And we are wondering with your curiosity in asking this question. We have been seeing these questions the relevance of this topic, and we could see that a lot of areas are touching with this plasma, including medicine, metallurgy, space, optics, everywhere. And plasma is touching us knowingly and unknowingly, and this technology is there. And before students are with their curious questions with us, and before we are going to that question session, we have to get some more reflection from our veteran scientists. I invite 𝗞𝗢𝗪𝗏 and Padmanabhan sir and Sundaramurthy sir to make comment on these sessions before we are going to these question sessions. Welcome, Bhatt sir. Please unmute your mic.
Yeah. Thank you for giving this opportunity of getting to know so much about plasma, because this is not, the domain is totally different for me. And then thanks to Dr. A.V. Ravi Kumar for excellent presentation. Excellent presentation, sir. Hat off to you. Such a nice presentation, right from the prelim, right from the elementary level for the students. I'm sure it's going to be a great knowledge for students. In fact, I have noted down so many points based on your this thing, which I would definitely go and questions as such. I was not aware that plasma is pervading so much, so many domains. So it is something I can imagine now our future is going to be in the end. University is 99.9999% is plasma, you are telling. So the question is, I'm sure I got some exposure to this subject. Thank you so much for that, and thanks to Your Space Club. Always the Your Space Club webinars are really, so much of they are rich in knowledge, and I feel sorry whenever I am not able to attend few of the more than 95% of them I have attended, but others I have not attended. Thank you so much, 𝗚𝗟𝗨𝗕 sir and Kutty sir. And Dr. Ravi Kumar sir, especially, sir. So nice.
I always say this.
Yeah.
That everything that we have, that the calcium in our teeth, the iron in our blood, the iron in our DNA, everything has come from some star that went bust billions of years ago. So we are all in principle star children.
Yeah. I saw you starting with that Panchabhuta, so I was he corrected so well. So very nice. So I just leave it to others to make their comments. Thank you so much, sir.
Okay, sir. Please. Please, you are not audible, sir. Your mic is not working. I think the device is some problem. The mic, if you use dismantle your connected instrument, the mic will be okay. No, sir. I think some mic problem with you. That's why. Yeah. We are not hearing. Okay, then we could see from your gestures that you are so much appreciated and interested with this talk. Okay, thank you, sir. Yeah. And these are the two scientists from ISRO, former scientists, 𝗞𝗢𝗪𝗏 sir and Padmanabhan sir.
I know. Yes. I've heard of it.
Yes, sir. Okay, thank you. Then welcome, sir. Is another scientist former scientist and project head from ISRO.
Good afternoon to all. I think it's really an eye-opener on plasma. Probably whatever I know about plasma is very limited, but today, in fact, it was really awesome to come as clearly explained. It will be beneficial not only to the students. It is fellows like me also. It's a learning curve for us. Especially, sir, I have only two questions based on your presentations, which I have observed. But you are talking about this lightning arrestor for our launch pad, Has there been any kind of initiation has been done from any of the world launch or launch providers have done this or initiated this activity?
No. This is still under research development only. Only very recently that the people have been trying since last 10, 20 years. Because with the advent of extremely short pulse lasers, so that your peak powers are very high.
Okay.
You do very short pulse because femtosecond lasers.
Okay.
Nobody is using it. The university in Switzerland and some group in France also is doing such a study. They are still studying the possibility of, and I'm sure that someday this will become very useful because you can actually point the laser towards a cloud, which probably makes not being used is that all that energy comes in one microsecond. You cannot store. It is like
Yeah.
the water tank on top of your apartment, which is 6,000 liters. When that breaks, how much water can you catch? You can catch maximum 15 liters of our bucket 15 liters.
Yeah, that's
Same way. So tomorrow, if we develop large battery packs or large supercapacitors, which can in short amount of time can charge, then definitely we can use.
another question was regarding the garbage and then using it for the lightning purpose. That was another good thing. But I think these are all now with the government has to take initiative and then we'll have to progress. Probably that is another clean way of utilizing the garbage and then we can get energy. Okay, because I don't want to stand the students because they are much more enthusiastic than us. Thank you so much. I think I once again thank Sajil Shop as well as our Kuti Shop for our enlightening. I think I never miss if there is a chance, unless otherwise I was busy with some other thing. Otherwise, I used to attend all the webinars. Thank you so much, sir. Especially thanks to Dr. Ravi on enlightening the plasma. Thank you.
Thank you, 𝗦𝗧𝗧 sir, continuously supporting our program. You are not our part. And next we have Dr. Abdul Nasser UK, who is the principal of Diet Kozhikode. And there would be a exhibition on plasma. The General Education Department is an exhibition. The program under District Administration is going to host that thing, and he is the head of that program. And I invite Dr. Abdul Nasser UK to mention something on that also and in our talk. Welcome.
Thank you, Shajil sir. Can you hear me?
Yes, sir. Yes, sir. Please.
Okay, definitely. It's a wonderful opportunity to hear Dr. Ravi sir about the Plasma Research Institute as well as the various activities engaged by the research institutes. Myself and Shajil sir met the different activities and your exhibition at Ernakulam. I think it's before 3 or 4 months back, and we personally met. And we are amazed that this program has to be conducted in Calicut also. So that's why I think we got an opportunity from IPR to do this in Calicut also. So our students can get the first-hand experience and directly they can meet and engage with the eminence and connoisseurs in this field. So whatever the Bhatt sir as well as the Patnavasan sir and all of that say, I'm also not taking the opportunity of the students. So we can hear the questions and the queries from the students. Thank you, Ravi sir. It is a wonderful presentation you done related with the plasma. It is an eye-opening for me too, because I am a novice in this field. Thank you, sir. Thank you once again.
Okay, thank you, Abdul Nasser sir. Words and this first time after this talk, the students are getting an opportunity to see all these things directly with their hands-on experience at Calicut in the coming September. Its tentative date is 4 to 8. That will happen here. And I could see, Deepa ma'am here, Deepa Martin, and I think if she is available, I invite Honorable Deputy Director of Education. Madam, are you there? Madam? Hello? Okay, I think she is not available when he's there, he'll get a chance to that. And it's time for Nila and Ramisha to handle the questions and sessions. And Nila, are you there?
Yes, sir, I'm here.
Okay, okay. And
Am I
Remisha is also there. I introduce Remisha is from Calicut Girls High School. She also will be there. And both of you can start. Nila is a student from it's a gifted children program part, and is part of your Space Club nowadays. Nila, please continue.
Now we are moving to the most anticipating or most awaited part of the plenary, which is the question answer session. In this session, our respected speaker has given a wide idea on plasma, its features, application in a short period of time. We have received from the students, and I will call everyone one by one, and you will have the chance to interact with the speaker. First of all, Fatima Rana raised a question. Fatima, you can unmute your mic, introduce yourself, and interact with the speaker. Fatima Rana.
Hello.
Will create almost 10 times or 15 times the temperature of the sun's core. Remember that. By putting it will show that it can generate 500 megawatts of energy. That is what ITER is going to do. And since no single can do it on its own,